Hi, and welcome to this webinar on load security and sustainability. I'm Andrew Mawson, Chair of the IOSH Logistics and Retail Committee, and I'm exceptionally pleased, because I've met him before, to introduce Ollie. This is Ollie from a company called Lindum Packaging, and they specialise in helping companies to achieve load security and sustainability. I'm sure we've all had instances when we've been moving goods where we've thought that pallets may not be as sustainably packed or indeed secure as they should be. And hopefully what you're going to gain from today's presentation is that there are options to make sure that our goods get from A to B in the right condition and to the end user in the way that they're expected. We're all part of the transport chain. From the consignor or customer that loads the product onto the vehicle, through the operator, and of course down through to the driver. So we all play a very significant part in making sure that any load gets from A to B in the best possible condition. A lot's made of load security, and in particular strapping and making sure that the load on the vehicle is safe. An equal amount of priority, which I hope you will see from today's presentation, is that an equal amount of priority should be given to the actual pallet. How is the product secured to the pallet, and is it safe, and is it sustainable? And we talk a lot, don't we, about shrink wrapping and making sure that products wrap correctly. I think you'll see from today's presentation how really, really important that is. So, without much further ado, can I remind everybody to try and keep your microphones on mute? There will be a Q&A session at the end, but please use the Q&A button on your screen to raise any questions as we go. And we're more than happy for you to get involved in the chat on the Q&A button if you've got responses or other questions that come up as we go. At the end, just to remind you, and I will remind you again at the end, this session is recorded, so it will be available on the IOSH web pages for you to view if you've missed it or if you want to see it again. And without further ado, I'll hand over to Oliver, because I don't want to steal his thunder and do his whole presentation before he starts. So it's all yours, sir.
Thank you very much, Andrew. It's a privilege to be asked to speak for IOSH again. So I'm going to start by sharing my screen. And Andrew, if you could just confirm that you can see that.
Yep, that's excellent. That's all up and running.
Excellent. So we're just going to spend the next few minutes just discussing how road safety is impacted by poor pallet stability. Pallet stability is an incredibly important topic, and I dare say often overlooked. And we're also going to focus on, more importantly, what we can do about it. So I'm from a company called Lindum Packaging. We've made it our core focus in the past few years to improve pallet stability and to come up with methods of improving packaging to the point where pallets are deemed as stable in the road network. So I'm going to start by looking at some interesting facts as to palletized logistics. So in the UK, there's around 60 million new wooden pallets are produced and put into the network every year. And this is just to give some kind of context to the scale of the logistics network that we're all part of. And there are somewhere to the tune of 150,000 tons of pallet wrap used every year in the UK. And I thought this was particularly relevant to bear in mind, because if you happen to be part of a large organization that might be using 100 tons, 150 tons, maybe 200 tons of plastic stretch film in a year, you need to consider this, because you might be as much as 1% of the UK market. So so decisions and changes that you make have a significant impact on the country as a whole, and not only our plastic usage but our road safety levels. And we estimate that there's about 750 million pallet journeys made every year within the UK. So it is a significant number. And obviously, considering that, pallet stability should be a high priority for all of us, as I believe it is. You've all taken the time to come on this webinar today, which just demonstrates that it is being more and more recognised as a high priority topic. So we'll just look briefly at what are the costs of poor pallet stability. Now, there's the things that people always say first and foremost: loss of damaged goods, the cost, additional transport. So if a pallet falls over, or if a truckload, you get a shot load and it's rejected by your customer, obviously you've got transport costs to get it back. You may have to credit your customer. Then there's a whole lot of other things that are often unseen. The reputation of your brand when you get another shot load turning up at the same customer. The rework costs are often just overlooked. What does it cost you to clean up any spills? What does it cost the environment? It's critically important. Customer service time. How long is it taking your people? Personal injury is a massive risk. If a truck has got pallets on it that have partially collapsed, there's a risk that they could fall out of the truck as you open it, and it poses many challenges in offloading. What's the impact on your ongoing supply chain? Many logistics companies talk to us about the impact of trailers with a shot load being tied up for 5, 6, 7 days while that load gets dealt with. All these things have a significant cost associated with them. So we're going to go on to look at some statistics that I find quite scary. UMOS tell us that every hour in the UK, across Europe and the UK, every hour, statistically, somebody is injured or even killed by insecure cargo. So that's a scary number. Considering that's just Europe and the UK, that's not even a global number. And then Packaging Digest did some research a while ago, and as a result of their studies, they come up with that an average of 2% of all palletized goods can arrive at their destination with some form of damage. And 2% is actually, when you consider the volume of palletized goods there are in the UK, that's 750 million journeys we just looked at. That's a significant number. And according to the government, in 12 months, the amount of road freight in the UK was 1.26 billion tons, which also just puts into context some of the numbers that we're talking about. So what are the impacts of poor pallet stability? Let's just think for a moment about what happens when a truck arrives with your customer with pallets collapsed against the curtain. So you can see the picture on the bottom of the screen there. You've got some products that's collapsed against the curtain. How do you actually go about dismantling that safely? If you open the curtain, the products, in that instance, will certainly fall out. So it takes time, effort. Trucks have to be unloaded manually through the rear doors. Some of these things take a significant amount of time, and on a busy loading dock or unloading dock, you just don't have time for this sort of issue. And that I just wanted to draw your attention to the picture on the top right. This was it was an incident that actually happened within our own network, where it was a few days before Christmas, a number of years ago now, but this is one of the incidents that really got us, I suppose, because it was personal to us, it got us on the journey of improving pallet stability. But this truck had driven something like 2,000 kilometers all across Europe to make a delivery to one of our clients. And it was just a few days before Christmas, and they were offloading it And as the driver drew back the curtain, they'd experienced a movement in transit, and I think it was something like 3 of the pallets were leaning against the curtain, and he didn't notice as he pulled the curtain back, and the pallets catastrophically collapsed, falling, 2 of them falling out of the off the bed of the lorry, and unfortunately caught him on the leg. So he suffered a very nasty injury, broken leg injury, and of course he had to then be taken for medical treatment for that. And whilst the on paper the cost of it was minimal, yes, there was some damage to pallets, but there was a real human cost to this, because that poor driver was from I think he was from Bulgaria. He had been hoping to get back to his family that Christmas, and because of an incident like this, he was injured in hospital for the duration of the Christmas break. And to us, that was entirely unacceptable. And it's one of the things that really got us thinking long and hard about, surely there's more that we can do to improve pallet stability. So that's just one of many examples. Now, bear in mind that UMOS tells us that this sort of event can happen very, very frequently, as often as once an hour across Europe. So should bear that in mind. So we've just looked at some of the severity of the impact of poor pallet stability. And every manufacturer, and indeed many of you logistics people, are under severe pressure to reduce the amount of plastic you're using. It must be more sustainable. You need to implement recycled content. But we know from experience that everything we do, which is the expression we got out there, every action has an equal and opposite reaction. So everything we do has some counter. So if we reduce plastic, what does that do to pallet stability? Well, logic would tell us that it probably reduces pallet stability. It's not always as clear cut as that. We try and implement recycled content. So there's a huge drive across the market to put stretch films with 30% recycled content, which is predominantly driven by the UK plastics tax. So we do know that many recycled content films perform differently to virgin material films. So if you make that swap, how do you know how that's going to impact pallet stability? So if you're making any of these changes, it's really important to actually do your homework, do the testing to see what effects it's going to have on pallet stability, and ensure that the changes you're making are being done safely and that the risk is analysed. Lots of people come to us and say, well, how do you test pallet stability, right? Which is what I'm going to come on to. We did a survey just very recently, and across 8 different FMCG companies, every single one of them mentioned that when they change packaging, they do a transit trial. Well, we're gonna touch on this. There's two ways people commonly try for pallet stability testing, and there's this one here which we call the Timothy test. I think the name was coined because one of our pallet stability guys who travels around a lot and goes to many different warehouses, he observed once that he says every single warehouse has a Timothy. They're not always called Timothy, but that's a guy he's the guy that will come along, he'll shake the pallet, and he will determine whether that's stable or not. As you can see here. So we shake the pallet. Is it stable? Is it not? And in this particular video, you can see quite clearly that there's an awful lot of movement going on there. And if you can move a pallet weighing 900 kilos by hand, we know that there's definitely some room for improvement. So that's number one. Do we like the Timothy test? Not really. What does it tell us? Debatable, because every one of our Timothys will give us a slightly different opinion. So that's one. The other way we always see people and companies trying to determine whether pallets are stable or not is the transit trial. So we've got a couple of examples here. So transit trial is, as you would all know, we put pallets on. It might be a new packaging format, a new bottle, new box type, a new stretch film, a completely different size or SKU. And we put it on the back of a truck and we send it on a journey. And when it comes back, we have a look, we open the curtains and we have a look. Is it upright? Has it collapsed? What's the condition? So we see on the left, we've got one that's clearly failed. So these pallets have, I would call that a catastrophic fail. Certainly no retailer would offload those. And then we've got one on the right, which was described by the logistics company in question as a textbook load. Everything's straight, everything's looking good. Now, there's a problem. We don't know, looking at that and looking at that alone, we don't know whether that textbook load is grossly overpackaged. We might be using far too much plastic. So it may be completely unsustainable. It may cost far too much for the company to actually implement ongoing. And we look at the one on the left, it's failed. We actually don't know what forces those pallets encountered. Did they have a very harsh emergency stop? Or were they just really unstable and they just collapsed like that under normal driving conditions? Was there a speed bump? Was there a harsh roundabout? So there's lots of questions that we don't know, which is why, although the transit trial is regarded as probably the most common way of testing for pallet stability, it's also very unpredictable, and it's not really a repeatable test. You can try your best to make it repeatable by sending trucks on the same route, but you still don't really know what forces those pallets encountered. So Lindum took it upon themselves to come up with better methods of pallet stability testing. We looked at what we needed to do. So we've kind of developed this process of testing, making changes, and obviously monitoring the data. So the testing that we do is predominantly is a UMOS test. So it's an emergency stop test and a repeatable test in a laboratory condition. So you see the picture on the right there shows a pallet on a test bench. So what we're doing is we're taking that pallet and accelerating it up to a set speed, and then we're decelerating it to a set G-force. And as we're doing so, we're monitoring with a camera, so we're watching the pallet. And I'm going to show you a couple of examples of this. But we're monitoring it to see what level of deflection there is, where the movement is, and it gives us some really insightful data to know where that pallet needs strengthening in order to improve its level of stability. And we can also do a similar test with, as you can see on the picture, a tilt test, where we can raise the angle of tilt and see, and likewise measure the level of deflection. And that's a static version of stability, whereas the acceleration or UMOS test is a dynamic and probably much more realistic, or we'll say real life test that we do. So we go through this process. We test a pallet, and that helps us to predict what's going to happen in real life on the back of a truck. And then, using our experience in packaging materials, we make some changes to stop it happening again. Obviously, we can then test and ensure that those changes had the desired effect. And then we monitor data. So then we look at actually how many instances of movement in transport were there before. We run the new packaging format for a period of time, and did it reduce accordingly. So that's a very simplified version of the process that we work through. And here I wanted to show you what a test looks like in real life. So this is two videos from our testing laboratory. So we've got two pallets. They're both the same product. And the first video is if you like, is a before. So we've got before and an after. So this is, as I play this video, bear in mind that this is a 0.5G test, which, to put that into context, that is, it's like a truck doing an emergency stop from 50 kilometers an hour. So it's quite realistic, and these things do happen on our UK road network. And this product is a canned beverage in a tray with stretch film around it. So there's the stretch film is in this particular example is very, very key to providing stability. So as the pallet comes to a stop, you can see it collapses. Obviously, this is very much in slow motion. But what's key here is that actually completely collapses. There's on the test bench, as you can see, there's a guard which stops it actually falling right over. But there is very little stability on that particular pallet. And this causes a huge, huge issue in the logistics supply chain. So then we set to and said, right, if we changed the stretch film for one that provides more holding force, and we apply it, we maximize the stretch, we maximize the holding force using the same packaging format, how stable can we get it? And this was the end result if I play this second video. So as you can see, as the pallet comes to a stop, we still get movement. There is still what I would call a significant level of movement, but the stretch film holds the product to the pallet. And as this test comes to a complete stop, the pallet returns back to its original position. So by changing one thing, and that is the stretch film, so we've changed the stretch film material and we've applied it in the best way possible. We've then taken that pallet from one that completely collapsed at 0.5G to one that actually survives a 0.5G deacceleration. And that is the difference in a retailer rejecting your load or accepting it. So I thought that was a really key one that we could share with you today. And then there's a second one that I wanted to share, which is these videos both play side by side. So this is actually it's a tub of paint, 10 litres of paint stacked on a pallet. And liquids are notoriously difficult. They're inherently unstable because you get movement inside the individual container. So if I play this video, you'll see the difference between the two. So on the left, we've got the before, and on the right, we've got the after. The before video is it's a stretch hood material, so it's a single layer of very, very heavy plastic. And as it comes to a complete stop, the pallet just doesn't stop moving. And those tubs of paint go right over. Now, you were probably so busy watching that one that you didn't actually see that there was such little movement on the after video. Excuse me. So what we've got here is one stretch hood. So a very thick or heavy grade plastic single layer compared to a very thin, what we call a nano film, stretch film on the other. And interestingly, when we cut off the plastic and weighed them, they were very, very similar amounts of plastic. I think they were within 3% of each other. So what we've done is used a different plastic, applied it in a different way, and got a very, very different result. I'm actually just going to play that again. If you also watch the pallet on the right, you can see we've got such little movement there. So that actually passes the UMOS criteria as being a stable pallet at 0.5G. Which, considering that's done with no extra plastic, is a significant win. Not to mention being a massive, massive improvement in pallet safety or road safety. So now we've looked at what some tests can look like. We're just going to look at what the root causes of pallet stability can be. So we've done a significant amount of analysis on this. One of them is driver behavior. Drivers, unfortunately, often get the rap for all the issues, which is caused by driver shortages. We all know what that's been. The roads, believe it or not, are getting busier, and on the roads, we all know that unknown things can happen. It could be potholes, it could be all sorts of things can happen, and our drivers have to cope with all these instances, all these. It might be traffic jams, all these things. Road conditions are also a key contributor. So what happens when there's a poor road surface? You might have massive potholes in the road, and the truck is experiencing different G-forces, and so are your goods on the back of the pallet. Sorry, on the pallet on the back of the truck. There might be sharp corners, challenging routes. All these things can add pressure to the palletized goods on the back of the wagon. In the warehouse or on the back of a forklift, there's a significant amount of vibration that happens to your pallet. A pallet could be dropped, even a fairly low level drop, or a pallet or a forklift dropping a pallet too quickly can have an impact on the product. We see people double stacking pallets. Obviously, that gives a level of compression, and sometimes it damages the top layers of pallets. Andrew and I had a discussion the other day about the damage that can happen when you stack pallets and then have to put a strap over the top of a pallet. Damage can happen to the top layer. It can lead to unstable loads. We've touched on this already, but packaging performance. So we're trying to lightweight packaging. We're trying new materials. We're trying recycled content. All these things are part of the root cause mix of poor pallet stability. Different pallet configurations, so different stacking patterns, the weight distribution on the pallet, whether or not you use interlayers, which is a topic in its own right. Do those interlayers have any anti-slip property? Do the boxes you use have anti-slip? All these things make a huge difference. So we are really here to consider what we can control. So what is within our control? And I think it's on all of us as part of the logistics network. We're all part of the same industry, and we need to just think about the fact that the purpose of packaging is to provide adequate protection from what might be unknown factors that will occur during its journey between manufacturer and end user. And we find actually incredibly often it's perhaps not thought about enough, what we call transit packaging. So the consumer doesn't normally see the transit packaging, so it's often overlooked. But between us, we must identify what the cause of damage is, and then make sure that our proposals of packaging, particularly transit packaging, I would say. So this is your stretch film, it's layer sheets, it's cardboard corners, and we must use that and apply it in the most effective way, because to just put more packaging on is simply not an option. Most often it doesn't actually have the desired effect. I went somewhere the other day where they were using a stretch hood on a pallet of very difficult to, it was a liquid, again, it was another liquid in a tub, and they were having issues with it falling over. And so what they tried to do is say, oh, we'll just double bag them. So instead of putting one stretch hood over, they put two stretch hoods on every bag. When we actually cut them off and weighed them, this was over 1.3 kilos of plastic on a single pallet, which is an incredible amount when you consider that for every kilo of plastic, there's just over 2.2 kilos of CO2 emitted just in the manufacturing of that plastic alone. So to be responsible, we need to make the best use of the resources that we have. And together we can do this. I think if we use the process of applying packaging expertise to get it right and testing to make sure that it's safe, we can actually make these reductions in plastic and do so wisely without impacting load stability. That really brings me to the end of our little presentation. I'm sure there's some questions. Hopefully there's a few questions. We can have a brief discussion, but Andrew, back over to you.
Thanks, Oliver, much appreciated. Yet again, you've excelled, because I think you've hit the key issues on the head there for us as a transport chain, in terms of how do we make sure that the goods that we load onto a vehicle, as far as reasonably practicable, actually make it to the other end. And that's always been a concern for us. And it's got to be, how do we involve the load security mechanisms such as straps, internal and external straps, the use of positive fit, to make sure that when the consignor or customer loads a product onto a vehicle, it's got every chance of getting to the other end and being delivered as it should be. We've got two initial questions, and one of them, quite interestingly, is what is UMOS? What does it stand for? Which I think is a great question, because I did wonder.
I should have touched on that. UMOS is a European body that is put together for predominantly for road safety. So it's UMOS that has come up with the testing methods that we use. So the test that I shared with the acceleration and deceleration, that is specifically there. It's essentially a group of logistics professionals that have come up with the testing methodology, and that is what we follow when we're doing our testing.
Good stuff. And the next one's been asked, and Robert asked the question, I'm going to rephrase it in a slightly different way, but Robert's asked the question, have you tested non-palletized goods in terms of your test beds and your lab and so on, and how that works on a vehicle? And I suppose I'll rephrase it in a different way from a retailer's perspective, is would it be possible to test non-palletized goods in this way as well?
Yeah, it's a good question, because yes, it is possible to. No, we don't very often. The whole testing process that we do is all about palletized goods. However, we have used our test bench to. One example was a product that was strapped. So we've actually on the bench itself, we've strapped a product to the bench, and then the acceleration deceleration was therefore to test the strength of the straps. I would say that's a little bit of an unusual method.
Yeah.
Normally straps are tested with well, Andrew knows more about that than I do, but braking forces.
Good stuff. And another question that's come in, which is quite interesting actually, is that obviously we talk about making sure the wrapping's right. So when we want to get that wrapping right, what part does training play in making sure that our colleagues at the consignor, at the operator, and at the driver element of the chain, what can we do in terms of training to get that right? What do you guys do in terms of helping people to make sure that wrapping's put on to the pallet properly?
Yeah, that is a great question. Predominantly what we're talking about here is machine wrapping. So where you got like a FMCG company, so they've got production line and an inline wrapper that's part of their production. So one of the key factors is with stretch film is that to maximize its holding force, you have to stretch it to the point, to its maximum point, so you get maximum holding force. This is kind of a whole subject in itself, but if your machine is set up to maximize stretch and the wrapping pattern is devised so that you get max holding force at the bottom, so strapping the goods to the pallet, and then obviously you reduce the number of rotations as you go up the pallet. Once you've set that, the machine will do more or less do the same thing every time. And a project that Lindum are working on at the moment is to come up with a IoT device or Internet of Things device that mounts to your wrapper to ensure that that wrapping program that's been set is adhered to. Because one of the common problems in factories is well-intentioned operators changing things on the wrapper, which can actually have, they might stop the film snapping, but they also might be under tensioning it significantly, causing problems on your road network later on. So there's a lot to making sure that that standard is adhered to, and it's an ongoing project that is, I'd say, being actively worked on and trialed to make sure that we can detect any changes to wrapping standards through a monitoring device before they become an issue.
Great. And I think a question that's come up a couple of times, which is a bit left field, but you'll probably appreciate where it comes from, is with the wrapping, is the wrapping that you use compliant with the plastic tax?
Great question. Yes, yes, but not always. What we find is we've got a huge number of different products, stretch film products that, yes, they are 30% recycled, so they do meet the criteria for the plastic packaging tax in the UK. However, in some instances where we need the absolute highest performance, maximum stretch, it is actually still more efficient to use a virgin material which can perform higher than the recycled materials. But those instances are fast declining, and every few months there's further advancements in performance on recycled films. So it's one to keep a very close eye on.
Smashing. And then we've had a question coming from Michael, and he's talking about when you showed the comparisons with the two pallets left and right, where one significantly went over, as it were, and one came back to straight. And he said it looks like the one on the left, it doesn't look like the pallet itself had wrapping round it, but the one on the right was fully wrapped. Was that kind of to demonstrate the failure more, if you like, or was that just a...
No, it wasn't to demonstrate the failure. That is true that during the test, the wrapping of the between the pallet and the product, it split. So the product actually came away from the pallet. That wasn't to demonstrate the test. That was a real life. That is what happened. So what we did in that instance is we took a pallet from the production line and put it on our test bench. There was no picking of the best pallet, and that was the result. So the purpose of that is so that it is a real life test. We know that that product, if we hadn't taken it off the line, it would have gone on a truck, and if that truck had done an emergency stop from 50 k's, that same thing would have happened.
So that was almost how it was actually wrapped in production, as it were. So
exactly,
yeah. Okay, good stuff. It looks like that's our bank of questions dealt with, which is great. So we're going to get an early lunch, which can't be a bad thing, unless anybody else has got any further questions, and it doesn't look like there's any coming through. But that's, thanks so much for that, Oliver, because I think it plays such an important part in what we do in retail and logistics, or logistics and retail. It's got to be something where we appreciate the part that everyone from the consignor to the operator to the driver plays in making sure that stuff gets from A to B safely. Great as always. Thanks for coming on. I'd just like to say a very special thank you to Amir from IOSH, who's helped us enormously. You'll probably see that the webinar feedback form is appearing on your screen. Please take the time to give us some feedback on that, because it helps us to make sure that what we present to you actually works for you as well. So on behalf of the Logistics and Retail Committee, have a good lunch, have a good weekend, and thanks for joining.